Yes, Toki? Oh, yes. Hello. Good morning. Welcome to the first breakout of the day. We're going to talk about home. There's an echo. Do you guys hear the echo as well, or is it just me? Oh, okay. Yeah, so I'm going to talk about Homelabs and building them for AI workloads. One of the misconceptions nowadays is that if you want to run AI workloads in your home lab, you need a crap load of hardware and eventually also money. But I'm going to debunk that. So my name is Johan van Amersfoort. I work as a chief evangelist at ITQ with a strong focus on cutting edge technology. And I see many of my colleagues in the audience. Thanks for being here. So building home labs for AI workloads. Why is that even important? Well, to me personally, I learn by doing stuff, and I need hardware or some platform or something else to run those workloads on. So hence this session. By show of hands, who has seen the GTC keynote last February? No one? One hand. Okay, so that's Jensen, NVIDIA's CEO, who is now announcing at that moment the chip he has in his hand is the Blackwell chipset, and that's the fastest GPU that's available right now, or well, it's not really available, but it was announced. And they also talked about the new architecture, the NeMo inference microarchitecture platform, the NIMS. Really awesome, and they consist out of like multiple different layers, and you can spin them up on your infrastructure. Really simple, and well, then you have the Blackwell chipset, which is really fast and powerful, and it has fast memory, like up to 192 gigs. Really awesome, and you can run that in a server room and buy all the hardware and now the question is, like, if they announce all of those stuff, and you as an IT person would like to play around with that, will that fit in your home lab? Well, it depends. Who knows this guy? Mark Huppert, yeah. He will run it in his home lab, obviously. So who knows this VMware Community Home Labs website? So it's a GitHub page. William Lamb created it. Awesome, cool hands. So the fact that he has his own metric, the average home lab without and with Mark Huppert. So apparently, and this is a screenshot taken from, I don't know, 2 years ago. So he spent 2 years ago little under 200 grand on his home lab. His words, not mine, but yeah, so he will probably be able to spin some form of insane platform up as a home lab. But for the common folk, that's not the case. So in order to run such a platform, the assumption is you need GPUs, preferably multiple of them, but we also know that costs a shit ton of money. So let's bust some myths. And before we do that, I want to take you a little bit into a journey of AI. What is AI, and how, because of the nature of artificial intelligence, like what kind of platform do you need? How do you size your home lab? What type of use cases are there? That's all what I'm going to cover in this session. So what is AI, and specifically what is deep learning? So deep learning works based on a neural network. So you can kind of compare it to your brain. And in this case, it has an input and an output. And the input in this case is something, well, it's a picture that kind of is a cat. And the outcome of a neural network is a predictability. It's a predictable outcome. Like in this case, a 96% chance that this is a cat. Now, what you do to train the network is you feed different types of pictures into the network, categorized, so dogs, cats, and Ewoks. You feed that into the neural network, and based on what you do, it trains the network and it makes connections between the individual neurons. And these connections, also called parameters, will help to define, if you feed another picture into that network, what the outcome will be. So in this case, the prediction is a percentage of dog, cat over Ewok. So like you mentioned, to validate the network, you feed another picture into the network, and the outcome is, in this case, it's probably 45% dog, 3% cat, and 52% Ewok. Now, in order to do this, to run such a computational workload, you need a resource. You can run it on CPUs, you can run it on GPUs. But the main difference between those two is that a CPU has, well, on average 4 to 24 cores, really powerful cores, real complex cores, can basically run any type of computation, whereas a GPU has thousands of cores, or in some case, a little bit less, but I'll cover that later on in the session. But these are less complex cores, really good at matrix computations, and run that in parallel. So this is an example of a framework based on TensorFlow, and in this case it runs on Skylake, so it does image recognition of, in this case, flowers, and you can see it recognizes approximately 4 images a second when running this on a Skylake CPU. And in this case, the CPU is fully occupied, so it runs on a 100% utilization. If you run the same process on a GPU, and this is a V100, so it's a quite older GPU, you can see it runs approximately 870 image recognitions a second. So that's insane. And in this case, the GPU is fully occupied, but the CPU is still capable of doing other stuff. Like if you would run this on a virtualization platform, you would link the GPU to a virtual machine, but the CPU is still capable of doing other things. Like you could run it on vSAN, so vSAN could be still being processed by the CPU. The same with NSX, etc. So it's really important. Now, when looking at AI and deep learning in particular, or as part of it, there are different types of workloads. What I'll be covering in this session is mostly computer vision and a little bit of conversational AI, but there are multiple forms of artificial intelligence that we're currently seeing in the infrastructure and in the industry. So computer vision. What I'll do is I'll show a couple of projects that I've been working on personally. So personal lab projects, if you will, just to get familiar of what the technology does. And the stuff that I'm going to show will involve every project runs in my labs, and I use technology that I, for instance, got through the vExpert licensing. So it's all covered through that. Everything I show can be downloaded today through, for instance, the vExpert licenses. So the first project is a project I called STIG, from a super awesomely trained intelligent guiding system. So the gist here is I wanted to know what it is to train a self-driving car. Really. So I'm going to show a couple of things. What I'm going to show here, first of all, is the basic platform I used to train it. So who knows what a Jupyter notebook is? Oh, a couple of hands, good. So this is basically an online IDE, if you will, specifically built for data science. And what you're looking at is how to train a network. So I'm showing in front of the camera a couple of objects, taking pictures. And now I'm going to train the actual network, or the model, if you will. And I'm doing that a single epoch. It says epoch, and that's the iterations, the number of iterations you pull data through a model. You see it trained right now, and the accuracy is approximately 0.9. The higher the accuracy, the better the model will work. What's really cool, and this is a little bit of an older video, but you can see at the top right, it runs on BitFusion. So BitFusion was acquired, I think, in 2019, maybe 18. A technology you use, or you could use, to offload CUDA instructions, so computational API instructions, over the network. And I think still part of that technology is being seen in the current Broadcom portfolio. But what I like the stuff I do here requires a GPU, but there's no GPU in this virtual machine that the platform is running on. That's running on BitFusion. Now what you can see is that objects I put in front of the camera are being detected, and in the sliders you can see what the predictability is. Now looking at the accuracy is now 9.65. If all goes well, you see that I'm holding the Powerball in front of it, but it doesn't do anything. I show an ITQ avatar and it says 1. A book, and now if all goes well, we'll dive a little bit into BitFusion. No, okay, let's go to the next section. So what I did, I used the BitFusion technology to train a model. And this is basically the workflow I went through. So I was driving, literally driving, collecting data from driving the car. And with that data, I trained a model running basically in a container. Using the Jupyter Notebook platform, I got visibility into what I was training. And I used BitFusion to offload all of the CUDA instructions to a GPU. Now, if that model is trained, you take that model and you put the model, the neural network, into what we call an inferencing app. And the inferencing app basically takes the data, has an input, in this case a visual input, validates that in a neural network, and based on what the neural network determines, it uses controls to drive left, drive right, hit the brake, throttle. So it uses a visual input, in this case of a camera. I'm driving somewhere, I determine an object, and based on the object, I need to go left, go right, etc. This is what it looked like in the old architecture with BitFusion. Now, Private AI Foundation was launched 2 years ago, so who recognizes the slide? A lot of hands, good. Based on a new architecture, I kind of redefined the platform. So now it looks a little bit more like this. So the driving and the collecting of data still looks the same. Instead of using BitFusion, I now run the container with the application directly on a Kubernetes platform with the GPUs attached. And now the distributed app has a little bit different components. So it still has the neural network, but it now also has a vector database. The inferencing engine and the front-end app are still the same. And this platform works based on a recurrent neural network. So what means I have a model, I'm driving, and as soon as I hit an object, the driving application gets punished because it shouldn't be driving against an object. So what now happens is that you're currently re-evaluating the things that you do. And that looks a little bit like this. So I'm training, I have a model, it runs in the application. As soon as new data is being collected, it's being put into another training phase and being put in a vector database. So the driving will still improve. Now, what it looks like is a little bit like this. So you see the neural network running there. You see the driving sim there. I start the neural network at the right in a bit. So Mario does nothing. As soon as you start the neural network, you can see the visual input. So the square above is literally what Mario is seeing, and the tiny rectangle below is the controls. So left, right, left. So you can see that based on what it sees in the neural network, it determines what to do. And you can also see that the driving skills are not yet what it should be. But it is learning, so it's constantly improving based on the fact that it now hits a pipe, it will be improving, constantly improving. The whole idea behind this is if you let it drive for like 2 hours, it'll win every single race. If you want to play around with this, it's called MarIQ. You can find a YouTube page from Seth Bling. who built this, it is really awesome to play around with. You get basically an idea what it is to train a network as well. He has a perfect explanation on how to create training data and put that data into a neural network. So this all runs in a lab. In this case, I run it on an RTX 6000, but you can simply run this on a cheap GeForce as well. A great way to start your own journey. A little bit about conversational AI. So I'm not going to cover this in depth. If you want to know more about the Private AI Foundation platform and how to run conversational AI applications, I'm going to talk about that in the next session. So we started a project, or I kind of started a project called Kobe, and now it evolved into something completely different, which I'll cover in the next session. But the whole idea was to also play around a little bit with a privately built ChatGPT application. This is really cool because I'm using a GPT model based on LangChain and trained a model with my own 2 books and a little bit of VMware's online documentation. And it runs in my lab without GPUs. Specifically, this runs on my Synology NAS. So I built and you can, in a bit I'll show a link, you can download it yourself, play around with it. You don't need any GPU hardware to run this application. So, a little demo. And again, this runs on my Synology. The only thing you need is an OpenAI API key. But what I did up front is upload a lot of documentation already to the application. And now you can basically ask questions about anything you did. So it now knows that stuff from my books. And it also knows if it's finally the year of VDI. Apparently that's not a yes or no question. It will probably never be the year of VDI. If you want to play around with this, and this is pretty cool, I built this on Hugging Face. So I built a space on Hugging Face, and this is even more awesome. If you want to play around with GPUs, or with AI, you don't need a lab, or you don't need any local device for that matter. Hugging Face provides you, and that's what I'm going to show in the next demo, an online environment where you get 2 virtual CPUs and a complete runtime environment to build this. So if you create a new space or copy an existing space, doesn't really matter. Is the demo running? It's not. Oh, now it is. Yes. So I'll share the link to this space in the next slide so you can play around with yourself. But if you look at the settings, so first of all, you can, whatever you build, you can run it in Docker. You get the clone command, you pull it whatever you want, wherever you want. But second, looking at the settings of the space, you can now see it runs on CPU. That's for free. If I would like to run it on like a GPU, it costs me 60 cents an hour to do so, and I can quickly switch from CPU to GPU, whatever I want. It is, when creating it, it is public. You can change it to private if you want, so if you just want to play around with your own stuff. But it's very powerful. The only thing is, obviously, it runs on a platform that's shared by many people, so you don't have any predictability when it comes to performance. But still, if playing around is what you want to do, this is a perfect platform to do so. If you want to look at the space on Hugging Face, this is a QR code. I used the platform to basically learn about what conversational AI is, how simply it is to build an application, and we took this idea into the next iteration, which we call Project Einstein, and that's what I'm going to share in the next session. So let's talk a little bit about hardware. I already explained what this is. This is the Blackwell SuperPod DGX awesome infrastructure thing that comes with a huge price. and a huge heat generation and power consumption and the whole shebang. Um, I don't think a lot of companies, well, a lot of companies can afford this. It's mostly the hyperscalers that will probably invest in it, huge universities. But for other organizations, you still want to play around with AI. I think VMware did a really good job in together with, for instance, Dell and NVIDIA to build that private AI foundation platform. And this is already a lot cheaper than the Blackwell SuperPod, but you want it to make even more cheaper if possible. And a GPU like this, like an A100, this is a pair of A100s, already costs around roughly 35,000 euros together, a pair. That's insane. So for normal folk, that's especially when want to play around with that in your home lab, that's not achievable. So I bought a second-hand Quadro RTX on eBay for even little under 900 100 euros. And the cool thing about this card, it's actively cooled. It supports vGPU. It has 24 gigs of frame buffer, and it fits in basically any machine. So if you want to play around with, AI applications that do require a huge amount of frame buffer, this is a great choice. Now, there are more choices. There's so what's really cool is that the CUDA framework that you use to offload computational API calls to a GPU requires a level of hardware. And if you look at, there's a matrix on the NVIDIA side that displays all of the individual CUDA versions and the GPU architecture that is supported. Now, in a next demo, I'm going to show an application that I recently built called based on the NVIDIA DeepStream framework, and that requires CUDA 10.2. And 10.2 is already supported within the 1030 or the 1000XX architecture from NVIDIA. This is a $60 GPU that you can buy new that supports CUDA, that runs deep learning workloads, AI workloads, for relatively nothing, and it doesn't require cooling. So it's just 75 watts. That's enough. And honestly, I think there's even better platform, which is the Jetson platform. Who owns a Jetson? Good. 2. I built this in the last couple of weeks. These are also 2 Jetsons. The Jetsons are awesome. It's basically a Raspberry Pi on steroids. It has a GPU based on the Maxwell architecture. So it's an older architecture, but it has 128 CUDA cores and 4 ARM cores. Based on that combined, it's a powerful platform that's capable of running deep learning workloads. So what I'm trying to pull off is all of the previous GPUs. No, this one at the side, it has 75 watt max consumption, power consumption, but the Quadro RTX, all Quadro cards that have active cooling and require an external power input, they will easily consume 300 watts. Easily. That has not a high wife acceptance factor, especially when running that in a cluster. So, and I wanted to learn a little bit more about Kubernetes and how to spin up those modern workloads on a containerized platform, hence the investment into the Jetson platform. So I bought 2 second-hand Jetsons on, again, eBay. And then, who owns the vExpert NUC we got a couple of years ago? Great device. So this platform consists out of 2 Jetsons, the vExpert NUC and a Ubiquiti switch. It runs Ubuntu K3s, which is a lightweight version of Kubernetes, built by SUSE. And all of both the Jetsons run Jetpack, which basically is a distribution of Ubuntu, but completely filled with all of the necessary tools you need to run AI-related workloads on the Jetsons. And the cost, everything together, was, well, approximately a little under 400 euros for an entire cluster. And the best thing here, it consumes 30 watts. It's completely silent. The fans that run on top of it support PWM, so they'll start to spin up when the I think when the thermal threshold exceeds 50 degrees, which it hardly does. So it's completely silent. The switch is powered by the Jetson. No, sorry, by the VXpert NUC. So it's simple. And I had my 30-year-old Lego Technic kit still available, so I built a Lego case out of it, and I think it looks decent. Could be better, but for now it's decent. So what I want to do is show a demo based on an application I recently built. So I mentioned the NVIDIA DeepStream platform, and one of my colleagues who is currently working with a customer that has, how do I tell this in a way that I'm not mentioning what the customer is? Well, they have a shit ton of video to analyze on a day-to-day basis, and they use the NVIDIA DeepStream platform to do so, but they do that with a shit ton of hardware. They have multiple expensive GPUs, but they still, in basis, they still do the same thing. They have Ubuntu, they have a form of Kubernetes, and they use the DeepStream platform. So what you're looking at right now is, and I recorded the video yesterday, I'm in my garden with my son. I have my laptop in front of me. We're waving at a Ubiquiti camera. So that's a security camera, and it has an RSTP stream. So at the left, you can see that the DeepStream application is running on one of the K3S nodes. And this is, again, the Jupyter Notebook. You can see the application is there, and if I execute the terminal, it's going to start. So here you see an application called JTOP. It's running on the Jetson Nano. You can see that the GPU is slowly doing stuff, and at the far left below, you can see that the encoders and the decoders are also doing something. That means that it finds the GPU the video stream. If I now use VLC Player to open up the RTSP output stream from the Jetson Nano, and it is a little bit glitchy because obviously it's a tiny Jetson. It's not a huge ass GPU. But if I walk towards the camera, in a bit you'll see that it's now determining that I'm a person, as does my son. So the whole idea behind this project for me is, first of all, to know about what is image recognition in real time, how to utilize a enterprise-grade framework from NVIDIA called DeepStream, and how to manipulate the pipelines within DeepStream to do something. So in this case, the pipeline is defined from, I have a raw RTSP video stream from a camera. I'm importing the stream, I'm encoding frames, or I'm decoding frames. Within every single frame, I need to load some kind of model, in this case ResNet, and based on the data that ResNet has, I'm detecting objects. Next part is to visualize the detection of those frameworks into an output stream, encode the stream into a new RTSP feed, and then I'm able to open up the RSTP feed in VLC Player. For me personally, the next step is there's a solution called Script with a Y, and that's capable of importing any type of RTSP stream and convert it, for instance, to a video stream for Google's home automation, or for the platform from AWS. Well, all home automation platforms. So you can just look at the video stream, but it can also trigger something. So if DeepStream is capable of determining that someone, my cat, for instance, walks through the backyard, or the cat of the neighbors, I can trigger something. Like the cat of the neighbors is in your backyard. I don't know, kill it, or sent the dog out, something like that. But it's really cool. It's extremely powerful, and it runs on a Jetson Nano. Really, yeah, cost effective. So let's look a little bit to the software part of it. My preferred OS of choice, but for nearly all customers we talk to, Ubuntu is the preferred OS of choice, simply because if you look at the NVIDIA online repository of frameworks, they're all being tested on, for instance, Ubuntu. Most of the things that you can find, most of the scripts you can find, most of the repositories you can find, all work perfectly fine natively on Ubuntu. We do have some customers that do Windows, that choose Windows to run their model development, for instance, on. But I think it just makes sense to align everything. Hence, for me as well to run Ubuntu. Plus, Ubuntu runs fine on the Jetson Nanos. Kubernetes by itself was not that lightweighted. If you want to run Kubernetes on edge devices like Jetson Nano, in this case K3S is the platform of choice. Once I knew what to do, I got this running in 10 minutes or so. What I'm not saying is that the process in getting to know what to do took me about 3 weeks. And a lot of swearing and anger management and stuff like that. I'm actually going to do a talk about the anger management part of building a Kubernetes platform on some kind of SUSE event on the 27th of June. Yeah, it's the learning curve of Kubernetes is insanely steep. Well, we talked about Hugging Face, also an extremely interesting platform for starting your AI journey. And NGC, who's played around with NGC yet? Yeah, I would expect one hand at least. Yeah. So this is ngc.nvidia.com. The DeepStream framework I just showed, but also the Jetpack, everything that's related to NVIDIA and machine learning, deep learning, AI can be found here. So it's a repository, and what's really cool here, and I show that in the next demo, is they built their environment in such a way that every single framework you can find there is cross-tested to all individual frameworks that are part of it. So take DeepStream. DeepStream requires Triton, requires Tensor RT and other CUDA deep neural network. And everything is part of that, of a single container. It's cross-tested. But if a new version of an individual framework is being released, they release an entire container that has everything cross-tested again. So what I'm going to show in this case is I'm running Python locally on Ubuntu. I'm trying to import TensorFlow, and I'm not able to do that simply because TensorFlow does not live on this machine. Now, if I go to the repository of the NGC platform, of every individual, so I'm gonna look for TensorFlow in this case. And you can quickly find, first of all, the framework, but you can see the pull command. So who works with Kubernetes on a regular basis? Or like Docker or... Okay, so what you try to do when pulling Docker containers to your environment is that you keep them as small as possible, right? And as non-persistent, and you want to make those containers as lightweight as possible. These containers are easily somewhere between 6 and maybe sometimes 20 gigs. So if you want to run that locally, be sure to cater for the file size. So if we now do the same thing, after pulling the container, you can easily see that in a bit. So CUDA released 10.2, same thing. So you can run this on the cheap GeForce. If we now try to do the same thing, you can see that the GPU will be opened. And before NGC, it was one big voodoo process to build a platform to make it work. It's insanely complex. But this is fairly simple. Cool. So I covered Jupyter Notebook. What's really cool about the Jupyter Notebook is that you have both access to a console within your session, as well as to a real-time Python interpreter. So you can basically talk Python to it, run a cell, and you'll see automatically what the result will be. There's a shit ton of different plugins for Git, for I think even for Azure DevOps. So you can integrate this in your pipeline if you want to. So how to start? Well, talked a lot about hardware, software, applications, but it can still be steep. So there's a couple of really good resources that I'd love to share. First of all is NVIDIA Launchpad. It's kind of comparable to the hands-on labs of VMware by Broadcom. And these labs are really good. So they spin up an environment for you where you go through a lab and really get to know what it is to build or to utilize a framework, do your hello world kind of applications, but then focused on data science. And the second one, which is my preferred one to start with, is the NVIDIA Deep Learning Institute. There are multiple free courses you can follow. Like if you have a Jetson, there are a couple of Jetson-focused courses getting you fully up to speed when it comes to building your first application running on a Jetson, focused on computer vision, on conversational AI, whatever. So the different types of applications courses you can follow. This is really, really good. So to conclude, a couple of key takeaways. So not every AI workload requires a GPU, and playing around does not require a home lab. But in case you do want to accelerate, there are cheap options if you want to do that. And there's a ton of really good, useful resources to start your own AI journey. Now, some considerations. So the deep stream application I showed doesn't require a lot of frame buffer. What I did is I scaled down the RTSP stream from my security camera to have a limited frame bitrate, a limited number of frames per second, and that will help you to pull it through the pipeline. But like the customer we work with does 4K video. Yeah, that won't happen on a Jetson Nano. So like more frame buffer, bigger encoding and decoding chips will definitely help you to run more complex workloads. But since this is a topic on AI for home labs, and I want you guys to kickstart your own journey, like a cheap GeForce with 4 gigs or 6 gigs of frame buffer will definitely be sufficient. So any GPU that supports a higher version than 10.x will do. There are lower versions, but the modern frameworks like DeepStream will require a minimum level of CUDA. And what's really cool is that Intel and Google also have accelerators, but there's a huge but there. Intel has their forgot what the name was. Google has the Coral USB accelerator. They do support frameworks like TensorFlow and PyTorch, but most of the really cool applications that you see, the deep learning demos that I showed, will require CUDA. And if CUDA and the translation libraries for these types of devices are not available, you'll have limiting options to accelerate. And I saw this morning a news article that the Raspberry Pi 5 nowadays also, and it's available since today, has an AI accelerator or deep learning accelerator available as a hat you can put on the Raspberry Pi 5. So it's pretty cool, and it costs roughly around 70 euros. So if you want to know more about conversational AI, I'm going to talk about Project Einstein next in, I think, 15 minutes, 10, 15 minutes. And there I'm going to cover what Private AI Foundation is, why it is important, and what challenges we faced as an organization in implementing this. And those challenges are both funny as well as really confronting. So happy to share those. So are there any questions? No? Oh, one. Yes. Come again? For Private AI Foundation or for everything I showed before? Both, right. So everything I showed before can be licensed through the vExpert license. If you are a vExpert, you can get your licenses like that. I think, are there any other options to get? Oh, VMUG Advantage. Yeah, I'm not a VMUG leader. Oh, I am. Yeah, VMUG Advantage is also, I think it's $200, and you get the entire vSphere portfolio with everything, or VCF portfolio with it. But that does not cover vGPU. That being said, you don't require vGPU to run those workloads in a lab. You could easily do that with passing through a GeForce card. So if that is a step you want to take, so run it on top of vSphere. Doing that with a GeForce card is a good way, or a second hand, or even a new, if you have the budget, Quadro card will do. You will need vGPU licenses if you want to split the GPU in different chunks, if you will. Now, coming back to second part of your question, if you want to do that for the Private AI Foundation platform, I have no idea right now where to buy it. So there's a SKU. There used to be a SKU called VMware Private AI Foundation, no, AI Enterprise, based on VMware, and that was a SKU you would buy from VMware. But I currently don't know in the whole licensing. Fiesta, what the best way of doing that would be. There's probably going to be a number of sales reps here, so I would definitely ask them around. Good question, by the way. It's an add-on. Add-on on top of VCF. Ah, right. It's an add-on on top of VCF. You heard it from the chief technologist here, who apparently also is a licensing expert. Any more questions?
Yeah, so you just shown the Hugging Face stuff to run on
Yeah.
this platform, but I also thought that this was a platform that you can pull in trained models already on your own environment.
Yeah, you can. So Hugging Face is basically a repository of both models, applications, training data that you can get for free. And Hugging Face does support, for instance, pulling of a model, just a model for your own environment. In this case, I just used it to do something else, to build an entire application. But yeah, you can pull models there as well. What I'll show in the next session is, so we're not using a model from Hugging Face. Simply, it's a public repository. Anyone can post a model to Hugging Face. Literally everyone. If you want to run a model for a conversational application internally, and you want to ensure that the model you use does not contain information you don't want to share with your, so it's privacy. It needs to contain privacy sensitive information. That's not maybe the best way to do it. So we chose to use a Llama model that we got from Meta. And you need to go through a validation process at Meta to be able to download a base Llama 2 or Llama 3 model. Good question. Okay, so I'm out of time. If you want to know more again about Private AI Foundation, there we go. In, I think, 10 minutes. Thanks all for joining, and have a great day if you choose to go to another session right now.